Welcome to Sysrev, the intelligent platform for literature review and data curation. Briefly, Sysrev allows researchers to search for and store documents from a variety of sources and then collaboratively review those documents in an entirely virtual setting. Versatile in nature, Sysrev supports a wide range of review-based tasks, including extracting large datasets from machine learning, conducting a wide variety of literature reviews, including narrative, scoping, and systematic reviews, and even evidence gap maps. Sysrev has also been used as an educational tool in both research and classroom settings. This is the Sysrev homepage. On the top of the screen is a link to the pricing page, which we'll come back to shortly, a clear cache module, a dark light mode toggle, a search bar, your profile page, which allows you to edit your username, access and view your projects, as well as your organizations, change and update your billing information, your email, and access your settings. Quick note, your developer key can be found in your settings, which is why I'm not showing it to you now. Last but not least, we have a Notifications tab. If we return to the home page, on the right there is a module containing featured projects. These are all open access public projects with a wide range of topics and data. On the left there is a module containing all of the projects I've accessed and a few pieces of information. First, I can see the project owner and title. While each project can have many members, they can only have one owner. Owners can be either individual users or organizations. In fact, most of these projects are actually owned by Insilica, the creator of Sysrev, and one is owned by myself. Last, I can see which projects are public and which are private. Public projects are completely open access. That means that anyone with the URL can access the project and information within. Alternatively, private projects can only be accessed by the project's members. Which brings us to pricing. In support of open access science and fair data, Cisrev Basic is available for free. Cisrev Basic contains all the necessary features for most literature review projects. Cisrev Basic allows users to create as many open access public projects as they wish, invite as many reviewers as they require, upload as many documents as they want, and extract as much information as they can. Cisrev Basic users can review all the document types we support and utilize the basic labels, Boolean, string, categorical, and annotation. To learn more about the label system, look to our other demo videos. Cisrev Premium, starting at $10 USD per month, offers privacy as well as additional data curation and analysis tools. First, in addition to limited public projects, Cisrev Premium users can create unlimited private projects. Whether dealing with proprietary data, health information, or whatever the reason, privacy matters. We understand that not every project can or should be public. Cisrev Premium also includes group labels, a feature which allows tabular data extraction. If you imagine literature review as producing a spreadsheet where each row is a different document, then what happens when a document contains more than one row of information? Say the protein was unbound at a certain temperature and concentration, but bound at another. Group labels facilitates multi-dimensional data extraction on a per document basis. Last but not least, Cisrev Premium users also gain access to the Cisrev API, via which they can programmatically push and pull information from their projects. As I said, Cisrev Premium starts at $10 USD per month, but as you can see, that price is per member of the organization, and not every member of your projects needs to be a member of the organization. Let me give you an example. Let's say you are a postdoc with a team of 5 graduate students. As a lead, you probably want to be in charge of the administration of the project and simply want the graduate students to perform the review. In this case, you only require one Cisrev Premium subscription, as that allows you to create the project as you need, and then you can invite the graduate students as reviewers. The total cost in this scenario is just $10 USD per month. As a counter, let's say you are a professor with 3 teaching assistants and 100 students. Then perhaps you might want 4 Sysrev Premium subscriptions. Then you can let the TAs manage the administration of the project, still invite the 100 students, and have access for yourself for oversight. The total cost in this scenario would be $40 USD per month. Last but not least, enterprise contracts are for academic institutions and commercial entities that require priority support or additional development, such as the integration of a unique data source. If you think this applies to you, please contact us at info@insilica.co. Before we create a project, let's take a look at an existing one. This is a project overview dashboard for a project Insilica conducted on opioid use disorder treatment outcomes. This project is owned by Insilica and is public. We uploaded 413 articles, included 106, excluded 238. There were 70 conflicts, but 1 was resolved. There are 5 members of this project, 3 of which actually did review. As I start to scroll down, you can see a prediction histogram on the left. This histogram depicts Sysrev's prediction for whether or not an article will be included. The farther to the right, the more confident Sysrev is that it will be included. Green bars represent articles that were manually included by humans, and red bars represent articles that were manually excluded by humans. On the right, there is a bar chart depicting the extracted Boolean and categorical labels. As you can see, in this project, we were interested in which type of outcomes were being measured in OUD treatment clinical trials. If I click on any one of the options, say retention, I'm automatically redirected to the articles page of this Cisrev project with the filter for that option. Has confirmed outcome with value retention from any user. So this is showing a filtered list of the 58 articles that were labeled with retention. Sure enough, if I click Display Labels, I can see retention for each article. One interesting thing about Sysrev filters is that the URLs are hard-coded. That is, you can share the URL for the retention filter, and whoever opens the link will be taken to the same list. As new articles are labeled with retention, the filter is automatically updated. Filters are also applied to Sysrev exports. This is a great way to share subsets of articles based on content. Removing the filter returns us to the 413 articles that were imported. If I click on Add Manage Articles, as you can see, since I'm not a member of this project, the Sources tab is in Read-Only view. So let's switch accounts. In this account, I can see a few more options. First, I could add new documents, or I could disable current sources. Back to the Articles tab. As you can see, Sysrev defaults to the review standard of 2 reviewers per article, plus a 3rd reviewer when there is a conflict. This can be changed in the project settings. Let's skip the Data tab, as it will shortly be renamed the Services tab, as well as the Users tab, which contains a list of the project's members and gives 2 avenues for inviting more members. The Analytics tab, available only to Sysrev Premium users, calculates concordance for each Boolean label, with more label types to come. Concordance tracking makes it easier for project administrators to notice and manage issues early on in the review process. The Review tab lets us review, but this project is currently complete. And finally, the Manage tab opens a series of subtabs. We have already seen the Sources tab. Label Definitions lets the users define which types of data are to be extracted. Here we have the default inclusion Boolean, as well as a custom categorical label. The export page has a number of export types. The compensation page allows premium users to pay their reviewers on a per article basis And finally, the settings page. The settings page allows members to view and administrators to change the project's titles, settings, and user permissions. Public and private we have discussed. Article review priority dictates the strategy by which Sysrev delivers articles. Single means that every article will be reviewed once before any is reviewed twice. Full means that every article will be reviewed by every eligible reviewer before a new article is reviewed. And balanced is, well, a balance. This option allows researchers to prioritize speed, which is useful for machine learning models, versus completeness, which is required for systematic reviews. Allow unlimited reviewers tells Sysrev how many reviewers should review each article. No means that Sysrev will default to 2 reviewers per article based on the priority above. So single article priority plus no unlimited reviewer practically means that each article is reviewed once. Yes unlimited article reviewers means that every member of the project will review each article. 10 members, 10 articles, 100 reviews. This is quite useful for classroom or educational settings. Lastly, label blinding. Turning this option on blinds all the labels, ensuring that no reviewers are able to peek while doing their review. Lastly, on the right, I can see which users have which permissions and adjust accordingly. Let's make a Sysrev project. Step 1. Click the New button on the Sysrev homepage. Next, choose the owner. On this account, I can either create projects as myself or as a member of the InSilica organization. Next, give your project a name. Last, choose public or private. Public projects are open access projects that can be accessed by anyone with the URL. Private projects are only accessible to its members. This setting can be changed later. Last, click Create Project, and Sysrev will automatically redirect you to the Sources tab. Step 1 of any literature review project, find some documents. Sysrev offers a number of ways to import and even search for documents to review. Starting with the left, Sysrev allows you to import PDF files in 2 ways, as individual documents or as a zip file. If I click View Articles, I'm taken to a filtered article page. Clicking on the document will show me the PDF. Turning on the single page toggle will cause Sysrev to render the entire document at once, in this case 18 pages long. Alternatively, there are pagination navigation buttons to the right. Returning to the Sources tab, Sysrev also offers 2 avenues for uploading titles and abstracts from Pubmed. Sysrev utilizes Pubmed's API in order to offer a native search engine capable of handling complex search queries. But for now, let's just go with a more simple query, Angry Bees. Click Import, and the 5 articles are also added to this project. Clicking View Articles will take me to a new filter, and again clicking on any article, and I can see the title and abstract as well as some metadata imported from Pubmed. If you prefer to search the Pubmed database directly, you can also upload a .txt file of Pubmed IDs. Users can also upload titles, abstracts, and metadata in both .ris and .xml formats. That said, we highly recommend that users utilize the .ris format via the free citation manager Zotero. Briefly, the Zotero.ris export is very standardized and quite compatible with the Sysrev parsers. Please see our video on how to use the free citation manager, Zotero, to convert XML files to RIS for more information. Just like with Pubmed, Sysrev also has native search engines for clinicaltrials.gov and the Fda Drug Label database. As you can see, the clinicaltrials.gov search has a number of filters to better help you refine your query. Once you are happy with your search, once again, simply import, in this case, the clinical trials. If you click View Articles, you can once again see the types of information that have been imported. The underlying format of clinicaltrials.gov is JSON, which is a hierarchical format. Each one of the elements rendered here is an element on the page for this clinical trial. While in its pure form, the JSON can be cumbersome, the hierarchy can be leveraged. That is, if you know that there is always an element called brief summary, you can easily search for that element. Sysrev allows users to programmatically choose which elements are rendered, albeit that is for another video. If I warp back to the sources page, we can look at the next import type, Fda Drug Label. Once again, the Fda Drug Label search allows for a number of different filters, which can help you refine your query. Let's search for olaparib, which is a type of PARP inhibitor. Select Import and View Articles, and we can take a look at this document type. A little bit of a combination. Fda Drug Label consists of PDF documents along with JSON metadata. Fda Drug Label submissions are versioned documents, meaning that they are updated and changed over time, whether it's because the drug was repurposed or a new adverse reaction has been identified. The navigation at the top allows the user to access prior versions of a given regulatory submission. As I scroll down, I can see the submitted document itself. And then finally at the bottom, I can see the metadata tied to the submission in JSON format. As you can see, Cisrev is quite capable at integrating external data sources. If you have a custom data source that you wish to review via Cisrev, please contact us at info@insilica.co. We can integrate databases such as Fda Drug Label or simply access a server or file of your choosing. It's time to review. Upon clicking Review, Cisrev will automatically serve an article for review. The prioritization of articles, or rather how Cisrev decides which article to deliver next, is actually based on Cisrev's machine learning models. To put it simply, Cisrev delivers the article that it thinks will most increase its ability to predict in the future. The only default label on Cisrev is the Boolean for include, as it is the simplest decision in literature review. Does this article contain the information that I'm looking for, and does the article report enough information about the underlying methods that I can trust the data? Once I click yes or no, I'm able to save the article, and Cisrev automatically serves the next document. If you wish to review a specific article, such as from a specific source, you can always access the article and click Manually Add Labels. If I return to the Overview dashboard, I can see that all of the modules have been updated. While inclusion is a necessary decision, there are plenty of other data types to be extracted from articles, and for that we need labels. If you imagine a literature review as creating a spreadsheet where each document is a row of data, then the label definitions are the columns. Each type of label is unique in how it defines the information that can be extracted. The 4 basic labels available to every Cisrev user are Boolean, Categorical, String, and Annotation. The last label type, Group Labels, allows for users to extract tabular data and is only available to Cisrev Premium users. To learn more about group labels, check out our other videos. The Import Label button, when combined with the Share Label button, allows for labels to be shared and standardized across projects. Now let's make some basic labels. A Boolean label asks a simple true/false. Where are the bees? Angry. You can require an answer, which means reviewers must provide a response before saving. You can require user consensus, which means that reviewers must give the same response, or else Sysrev will store the article as a conflict. And you can designate an answer as inclusion criteria. That is, tell the user to only include articles with certain responses. In this case, I only want to include articles in which the bees were angry. Alternatively, categorical labels allow users to choose from a preset list of options. Once again, you can require an answer, you can require user consensus, and you can designate one of the available responses as inclusion criteria. Once again, we want angry bees. The string label allows users to give any response. You can still define the strings based on character length and using regex. Still, string labels allow for the most variation in answer, so be cautious in how you utilize. Quite often, a string label and a categorical label can be used in combination, such as a string label for quantity and a categorical label with options for different units. Last but not least, the annotation label, which is in itself a combination of string and categorical labels. The annotation label allows users to highlight text within a document and then tag that text with a label option. Now that we have more labels, let's get back to reviewing. We can now see the additional labels on the left. As you may remember, we said that the bees had to be angry in order to be included. But if I select no for angry and yes for include, we can see that Sysrev gives me a visual cue that I'm not being consistent with the expectations. Once I select yes for angry bees, the cue gives me a green light. Categorical labels work the same, except now I can choose multiple options. And again, strings are strings. As I said, the annotation label works a little differently. First, I select the annotation label, and then I must highlight some text. Once I have highlighted text, I can apply an entity and save. And go back to the labels. Once I've finished all of the labels, I can now save. And Sysrev once again delivers the next article. If I go back to the overview page, I can once again see that the modules have updated, including adding the new Boolean and categorical labels. And if I go to the articles page and display labels, I can see all of the information. In this way, Sysrev allows great versatility in the types and quantity of information that can be extracted. To learn more about how to utilize the basic labels, explore some of the other projects on Sysrev. To learn more about group labels, check out our other demo videos. So far, we have created a project, imported a bunch of different types of documents, and created some basic labels. Now we're going to take a look at the premium feature, group labels. Whereas the basic labels allow users to extract individual pieces of information from each document, group labels facilitate tabular data extraction by allowing users to extract multiple sets of the same combination of labels. In essence, the group label is a label of labels. Let's get started. Once I click Add Group Label, I'm given a slightly different input than the basic labels. Once I give the group label a name, I'm asked to add more basic labels. This is where the label of labels comes in. Let's recreate the same basic labels, but within the group label. As you can see, I can add as many Boolean, categorical, and string labels as I require. But let's stop here for now, save, and review. And you'll notice the group label is now included on the left side module. When I click on the group label, it opens the group label input module. Clicking on new blank row will add a new blank row. I can resize the input and then see a little more clearly. These basic labels within the group label work the same as before. Booleans are Booleans, categoricals are categoricals, and strings are strings. If I want to quickly change just one element, clicking the green button copies and pastes the information into a new row, which then can be easily affected. Clicking Toggle Editor will turn on more spreadsheet-like functions, which allow for multiple cells to be copied and pasted at once. You can still input new information in this mode, but the UI is a little less clear. As you can see, the rules for the other basic labels still apply. Last but not least, you can even share the entire group label using the feature Share Label. This is a project for our existing group label demo. Anyone can join this project and try out the feature by accessing the URL here. This project consists of 2 PDFs, both for the same MSDS of toluene. If I look at one and scroll to the bottom, I can see that the extracted data consists of 2 group labels, health effects and LD50 LC50. The first consists of 2 categorical labels and 1 string label. The second consists of 5 categorical labels and 1 string label. Let's say I wanted to extract the same information from our new demo project. Since I want to be able to merge the data later, I want to use the exact same format. Share Labels is a feature that allows users to import labels from other projects, thereby ensuring that all data is extracted in the same standardized format. To copy a label, go to Manage, Label Definitions, and click the Share Label button for the label you want to copy. Make sure you copy all of the code. Navigate back to your new project, Manage, Label Definitions, and then click Import Label and copy the code. You will now see the group label has been imported. As you can see, imported labels are linked to their source label. That is, if I update the original group label, then all of its clones will also update. This is useful for maintaining master lists, such as for adverse events. Still, if I want to detether the two, simply click Detach Label, and now the new group label is independent. Note, this action cannot be undone. Once I've detached the label, I can edit or add new labels as per usual. If I click Review, I see the new group label and can utilize per the normal rules. In this way, group labels allow for tabular extraction, greatly increasing the amount of data that can be extracted. Coupled with the Share Labels feature, which facilitates greater standardization, group labels are a great tool for creating large datasets. Now that we've created a project, imported some documents, and extracted some data, let's look at how the Sysrev filters allow users to quickly identify and share sets of articles, as well as the different modes of exporting on Sysrev. We've already seen how the bar chart on the overview dashboard can be used to access filters based on content. Here are the articles that have been labeled as true for angry. As a reminder, the filters are hard-coded URLs, which means that if anyone were to access this URL, they would see the same filtered list. Returning to the dashboard, these other modules are also links to filtered lists. But let's look at a slightly more exciting project. This is a project we conducted on opioid use disorder treatments. As you can see, one of the pieces of information that I tracked was my reason for exclusion, or rather why I was not able to extract information from the document. Some simply didn't have the information, but a number simply didn't have open access free PDFs. Once again, clicking on the label takes me to a filtered list for that response. If I go back to the overview page, let's instead look at the publications that I included and extracted data. As you can see, this takes me to a different filtered list with its own dedicated URL. The filters allow users to identify and share specific subsets of articles. Let's take a look at the filter types. Source will only show articles from a given source. This project's articles all came from a single XML import, and so the list is the same. Notice that you can either match or exclude based on a given criteria. So if I exclude all of the articles from the same source, then I'm left with no articles. You can filter based on consensus, as well as individual labels, the inclusion label, or any of the labels. So these are all of the articles for which I answered the include label with the value yes. Once again, 88 articles. If I quickly hit Display Labels, I can see the types of information that I extracted. Mostly came down to two group labels, population outcomes and treatment outcomes. If I want to see all of the articles that had treatment outcome extracted, I can. If I want to see all the articles that had treatment outcomes and population outcomes extracted, I can do that too. Filtering on user content is much the same, except that the filter only considers which user gave label responses, and it does not actually consider the labels themselves. The last filter is machine learning. More details later, but briefly, Cisrev automatically builds predictive models for inclusion, as well as every Boolean and categorical label. These models are available for use as filters. This is a histogram depicting Sysrev's predictive model for inclusion. The farther to the right, the more confident Cisrev is that an article should be included. The green bars were manually included by a human, in this case myself, and the red bars were manually excluded. As you can see, the models did fairly well considering that they were trained on only 175 articles. I wonder what these red bars are on the right. Okay, back to filters. Let's turn off these filters and add a filter for predictions. Let's look at all the articles that Sysrev thinks had at least a 75% chance of being included. And let's say I wanted to find those red bars from the histogram. So let's intersect this with the articles that I excluded. Include me, no. So here are the 4 articles that I excluded that Sysrev thinks should be included. As we can see, 3 of the 4 simply didn't have a free PDF, and the last didn't have the information that I was seeking. Perhaps it is worth purchasing these PDFs as the models are performing fairly well. Now that we have seen the filters, let's look at the exports. The first thing to know is that the filters are applied to the exports, which can be quite handy for sharing specific sets of information. Let's say I had a colleague who had access to some journals that I did not. I could export these 4 articles via XML or CSV and send the list to them. As I remove the filters, the export numbers update accordingly. In addition to simply sharing article metadata, there are 3 answer exports. Article answers only include 1 set of responses per article, whether due to agreement or by relying on conflict resolution. User answers includes every label response by every user, including conflicts and resolutions. Annotation export is the same as users export, but includes annotation labels, which require a special format. One final note is that the group labels also require special export. If I go to Manage, Export, I can see the same export options plus 2 more group label specific exports. As a reminder, a group label allows for tabular extraction. That means you are extracting multiple tables of information across multiple documents. A simple spreadsheet is unable to capture all of this information without becoming impractically sparse. To solve this, we offer 2 avenues. First, individual group labels can be exported as a CSV. So this export would show all of the population outcomes across the 175 articles merged into one CSV. Alternatively, you can export all of the project data in one JSON file. If you need help with manipulating JSON or help with any data manipulation, feel free to contact us. Last but not least, all project data, including group label data, can be accessed programmatically via the Cisrev API. Access to the Cisrev API is a premium feature. We have now seen how filters can be used to isolate interesting subsets of articles, and the hard-coded URLs and many modes of export allow those subsets to be easily shared. Now that we have seen how the filters and exports work on Cisrev, let's take a deeper dive into the machine learning. Briefly, Cisrev automatically builds machine learning models that predict for every Boolean and categorical label. This is a project that we conducted on mangiferin, a substance found in mangoes. To make a long story short, we were interested in macro-level human health effects of mangiferin. Since we were only interested in high-level data, that is, we did not need to be 100% thorough, we were able to leverage Sysrev's machine learning capabilities to optimize our time. As you can see, we only reviewed 206 of the 725 articles. We included some, we excluded some, a few conflicts, but they were resolved. As I continue to scroll, we can see a histogram. After a number of articles have been reviewed, Cisrev automatically builds machine learning models for each project on Cisrev. This histogram depicts Cisrev's machine learning model's prediction for inclusion. If I hide the unreviewed articles, this gets a little easier to see. The green bars represent articles that were manually included by humans. The red bars represent articles that were manually excluded by humans. and the x-axis corresponds to Sysrev's prediction. A 1 means that Cisrev is 100% sure that the article should be included, and a 0 means that Cisrev is 100% sure that the article should be excluded. A score of 0.5 means that Cisrev doesn't know. As you can see, the model isn't perfect, although it is pretty good for being trained on 206 articles. That said, when one accounts for the distribution of the unreviewed articles, we can see that it's quite handy. Over 1/3 of the remaining articles have less than a 2.5% chance of being included. So basically, we wanted to leverage Sysrev's machine learning to optimize our time. So that's what we did. We decided to be conservative and chose to include any article that Sysrev thought had at least a 25% chance of being included. That reduced the total number of articles from 725 to 292. Of the 292, 78 had already been included. And 24 had been excluded, which means that over half of the 292 articles hadn't been reviewed by any human. Well, we took those 292 articles, exported the articles, and imported them into a new project for further extraction. One of the reasons that we wanted to optimize our review was that we were paying reviewers $2 per article, but that's a story for another time. As you can see, this project consists of the 292 articles that we exported from the previous project. Only this time, we were extracting a lot more information about the health effects. Was it a positive effect? How was imagifarin administered? What organ was studied? And what species? As we've seen before, this bar chart acts as a link to filtered lists. Here are the 20 articles that were labeled as heart cardiovascular for organ. But let's say instead of looking at the labeled documents, I wanted to see which articles Cisrev predicted were which organ. As I said, Cisrev builds prediction models for every Boolean and categorical label. Let's say that I wanted to see the articles that Cisrev thought had at least a 75% chance of being in the organ heart cardiovascular. If I look at the titles, I would hope to see terms dealing with the heart. Myocardium, cardiomyopathy, cardiotoxicity. Not bad. If I look at any one of the articles, I can of course see the labels that were extracted, but I can also see the individual predictions made by the Cisrev model. Cisrev was pretty sure that this study had to do with rats, kind of sure that the imagifarin was delivered intravenously, and pretty sure that the study had to do with the heart and cardiovascular system, as well as blood and serum, which makes sense. Obviously, with more training, these models would perform even better. One very interesting thing about the Cisrev models is that Cisrev is only building one model per project, and that the single model simultaneously predicts for every label via transfer learning. One possibility with this is building ensemble models. Briefly, the Cisrev API allows users to programmatically push data to articles. In this way, users can push custom model predictions to Cisrev in the form of labels. Once this is done, Cisrev itself will learn from those labels and adjust its models accordingly. This is one of the many possibilities with machine learning and the Cisrev API. So far, we have created a project, imported documents, added labels, extracted some data, and looked at how to leverage filters, machine learning models, and export features to optimize our time and share our efforts. Next, we will take a look at how the Cisrev API allows users to deftly push and pull data from their projects. While there are many ways to access the Cisrev API, this demo will utilize the program RStudio Cloud along with the Cisrev package. You can learn more about and download the Cisrev package at r.sysrev.com. The home page includes details on how to install the package, and the Reference tab contains a list of the current commands. We will be adding new commands to the r/Sysrev package, so be sure to check in frequently. We have also made more information and code available on the r/Sysrev GitHub page, which can be found at github.com/sysrev/rsr. This is RStudio Cloud. It allows me to write and execute R code. Now the first thing I need to do is load some libraries, as well as provide my developer token. Here I've imported some libraries, and now RStudio is asking for my developer token. The Cisrev developer token can be found on your user settings page. Now let's pull in some data. As you can see, the next command line is get group label answers from project 81395. Let's take a look at project 81395. This was a project we conducted on how specific genetic mutations in prostate cancer affect treatment outcomes. Clicking on any one article will show what types of data we were extracting. Although it is hard to see the individual pieces of data in this view, as we extracted so much, in fact, we extracted over 10,000 pieces of data from these 13 clinical trials. By looking at the group label titles, we can see the types of information that we were looking at. Relative outcomes, such as hazard ratios, single outcomes ratios, such as PSA responses, single population outcomes, such as progression-free survival, and biomarkers. And now let's take a closer look at this last table. What this table shows us is the different genes that were monitored by this clinical trial, and whether a mutation of that gene was required for inclusion, was excluded from the trial, or if the trial simply recorded whether or not there was a mutation. Okay, back to RStudio. Now that we've grabbed the group labels, let's take a look at their names. Sure enough, those are the 4 tables that we saw. If we dive into the biomarker table, we can see the exact same information in a new format. Biomarker, what type of eligibility criteria it was, as well as some metadata about the review itself, the article ID, and username of the person who extracted the data. One of the big questions we wanted to answer was simply, are all of the trials looking at the same mutations? With just 1, 2, 3, 4, 5, 6 lines of code, we can begin to answer that question. And the answer is no. There is quite a lot of variation across the trials for which genes were being monitored. As the API is live, were we to add a new trial or new data and rerun the code, the plot would update accordingly. But let's keep moving. Next, I want to look at just one of the group labels, single outcomes ratio. Let's take a look at the top of the new entity. Now we can see the extracted information, what outcome was being measured, what the treatment was, other defining features, what the actual value of the outcome was, and again, metadata about the review itself. You can see that we even tracked where in the publication each data was found, in case we needed to audit our findings. Data is nice, but can be hard to interpret. Fortunately, with just a few more lines of code, we can build a forest plot of all of the single outcome ratios from the 13 articles. In this way, the Cisrev API allows users to programmatically access and manipulate data from their projects. With the new Set Label feature, users can even push data to their projects. This is useful for uploading metadata, uploading partially completed or outdated reviews for updating, or to push custom models. If you'd like to learn more about what's possible with the Cisrev API, contact us at info@insilica.co. Now that we've seen how Cisrev operates, let's take a look at how to standardize, replicate, and extend your research across Cisrev projects. If we return to our demo project and look at the labels, we can see that we've already pulled in the LD50 LC50 group label from the group label demo project. Let's go quickly grab the other group label. Navigate to the project, return to the label definitions, and click the share label icon for the group label you want, in this case, health effects. Make sure you copy all of the code and return to your previous project. Manage, label definitions, and import label, and now copy the code. The new project now also has the health effects group label. If we go to review, we can see that the new group label has been properly imported. But what happens if you want to copy and paste multiple labels? Well, then you can just clone the entire project. Cloning a project copies all of the articles and label definitions, but none of the label responses. Simply click Clone, designate who should be the owner of the project, and boom, it's been cloned. Quickly update the title for clarity, and maybe delete the old sources if you would like to begin anew. And with that, we have seen how Cisrev presents versatile tools to tackle any literature review or data curation project. To see Cisrev in action, check out our other featured projects, or just give it a try.